Hello, Algebra 2 class. So we're working with our trig functions here and really sinking into our brain what the relationships are for sine, cosine, and tangent. So we're remembering SOHCAHTOA. So, S-O-H, sine opposite over hypotenuse. Ka, the ka is C-A-H, cosine is the adjacent over the hypotenuse, and TOA. That stands for tangent is opposite over adjacent, SOHCAHTOA. So if you forget what the relationship is, you can come back to SOHCAHTOA to help you remember what each one of those trig functions definition is. So for our sine of theta that we're asked to figure out for this triangle over here, we're going to think what is the opposite over the hypotenuse. Now what's drawn in black here is your given information. What's drawn in red is what I have marked in after the fact. So I have figured out the hypotenuse of this right triangle by using the Pythagorean theorem. 16 squared plus 30 squared is equal to c squared. That's my hypotenuse. And then when I work that through, I find out c is 34. So I've marked in with a little thinking bubble the hypotenuse is 34. You're free to mark that in with your regular pencil, but I want to make sure you understand that if I give you the two legs, you can figure out what the hypotenuse is of any right triangle. I've also written in the abbreviations for opposite, adjacent, and hypotenuse of this triangle, given that this is our angle theta. So our hypotenuse here will always be opposite the right angle. The legs of that right triangle will always be the opposite and the adjacent pieces of the triangle. So if we're right next to angle theta and we're a leg, we would call that the adjacent side. If we are opposite angle theta, that is, that leg does not touch that angle theta, that would be the opposite side. So I've labeled that up to help me figure out what my ratios are for sine, cosine, and tangent. So for sine, I'm going to pick up the numbers on the opposite and the hypotenuse sides of my triangle. So opposite is 30 over my hypotenuse 34, and then I'm going to reduce that fraction down. 30 over 34 reduces to 15 over 17. If I can reduce, I must reduce. And if there's a radical involved, it needs to be simplest radical form. There's no radical here, so I've just simply reduced my fraction down to 15/17, and I know now my sine ratio for this triangle in relation to this angle theta is 15 over 17. Cosine of theta. Cosine of theta, by definition, is adjacent over hypotenuse. That's the ka side of our SOHCAHTOA. And so I'm going to find my adjacent side of my triangle, which is 16, and I'm going to find my hypotenuse, which is 34, and I'm going to write the ratio for cosine of theta as 16 over 34, which reduces down to 8 over 17. So the cosine of theta is 8 over 17 in simplest form. My tangent of theta will be the opposite or the adjacent side. Those are both legs, no hypotenuse when we're talking tangent. So opposite over adjacent in relation to this angle theta. My opposite side is 30, my adjacent side is 16. So 30 over 16 reduces down to 15 over 8. So my tangent of theta is 15 over 8. This order matters. So it's not 8 over 15. If I put 8 over 15, then I would actually be upside down, because then I would be the adjacent over the opposite, and I need to be opposite over adjacent. So it's really a good idea to mark which side of your triangle is the hypotenuse, which one is the opposite and adjacent side given a particular angle theta, so that you don't get mixed up. All right, sample 2. We're going to find values of x for the next 3 sample problems, and we're going to use our tangent, sine, and cosine trig functions to do so. So to find this x here, I'm first of all going to label the pieces of my triangle that have numbers or variables on them. So given that this is the only angle that is labeled here for us in our right triangle, we're going to write our opposite and our adjacent sides of my triangle in relation to this angle. Well, the leg that is closest to that angle, the adjacent side, is this side here, the side labeled 7. Opposite of this 18-degree angle, that leg, the opposite leg, is x. So I've labeled those in. I don't have any information on my hypotenuse, and I can't figure out its value because I don't have both legs with values for them. So I'm going to ignore my hypotenuse. I don't need it for this problem. I'm going to think about the fact that the tangent of this 18 degrees would be my opposite over my adjacent. Okay, so that's my thinking bubble for where I go next. Now I'm going to say the tangent of 18 degrees is x, the opposite leg over 7, the adjacent leg. And now I have an equation that I can use to solve for x. First, I'm going to multiply both sides by 7, and that'll give me 7 tangent of 18 degrees is x. Then I'm going to switch the sides just to make it more convenient for me, and I'll use a calculator to work this out. Again, make sure you're in degrees mode when you are using your calculator to get accurate answers. I'll see on my calculator display when I use my calculator that I have 2.274 and some other digits past that. I'm going to round to the nearest hundredth, and that would give me the value of x as 2.27. Next problem. Again, we're finding x. So the stuff in black, again, is the givens. I've written in the hypotenuse and the adjacent side of this triangle based on the 25-degree angle here. So I'm noticing this time that I don't have my opposite side labeled, my opposite side of my 25-degree angle, and I won't need it to figure out x in this case. I will be using the adjacent side and the hypotenuse side. Adjacent over hypotenuse, we'll recall, is cosine. So that's why I'm choosing to use cosine of 25 degrees as my adjacent side over my hypotenuse side, plugging in those numbers, 47 and x, 47 for the adjacent side, and x for the hypotenuse. Now I'm ready to solve my equation for x. This time I have x down in the denominator, so I'll go through a series of steps to solve this. One way is to multiply both sides through by x. That will get these x's to cancel out, and that will give me x cosine of 25 degrees is 47. Then divide both sides by cosine of 25 degrees, and we'll have x is equal to 47 over the cosine of 25 degrees. Use a calculator here. Your calculator will display 51.8587. Let's go ahead and round that off to the nearest hundredth, and x is 51.86. Last sample problem. This one's going to have us find x again, and this time we'll be using the sine function because of the information we're given. So the black part of the triangle and all the labels are given to you. I've written in hypotenuse and opposite. We don't have any information about the adjacent side here, so I'm not going to bother to label it. I don't need it. I'm noticing the sine of 48 degrees would be the opposite side or the hypotenuse. So I'm going to use that sine of 48 degrees to help me work out my answer. Sine of 48 degrees is equal to the opposite side, 19. There's my opposite of 48 degrees over x, the hypotenuse. Now remember, when we're talking about the opposite and the adjacent sides, we're always talking about the legs, never about the hypotenuse. The hypotenuse is always unto itself. So adjacent and opposite legs are determined by whether or not they are next to the non-right angle or opposite the non-right angle. All right, just like last time, now that I have my equation set up, multiply both sides by x, and that's going to get these x's to cancel out. And then x times sine of 48 degrees is 19. Divide both sides by the sine of 48 degrees, and you'll have x isolated. X is 19 over the sine of 48 degrees. Use your calculator. You'll see this on your display. Round to the nearest hundredth, and x will be equal to 25.57. So again, we determine whether we're going to use a sine, cosine, or tangent based on the information we're given. So going back to our sample 2, we used tangent to find out the value of x because we had labels for our opposite and our adjacent sides of the triangle. And opposite and adjacent, that ratio is your tangent ratio. Sample 3, we used cosine because the parts of the triangles that were labeled were the adjacent side and the hypotenuse side. And we recall that adjacent over hypotenuse, that ratio is a cosine ratio. And finally, on this last sample 4 problem, we use sine because we had labels on the hypotenuse and the opposite side of the given angle, 48 degrees here, and we recall that opposite over hypotenuse is our sine ratio. So we're going to use the trig function based on the information that we are supplied and can work with. So that completes all the way down to our last sample, sample 4. And so now it's time for you to move on to the quiz for this lesson. And we'll see you next time.